Hey everyone, in this video, I'm going to go over the LeetCode problem, maximum product subarray. So first, let's read the question. Given an integer array nums, find a subarray that has the largest product and return that product. And it also mentions that the test cases are guaranteed so that the answer will fit in a 32-bit integer. So let's take a look at the example. In example 1, the input array nums is an array of 2, 3, -2, and 4. And 2 times 3 gives the largest product. So the output is 6. And what they want to mention about subarrays is that a subarray has to be contiguous, which means that the elements in the subarray they have to be consecutive when next to each other in the actual array. So for example, 3 times 4, or say 3 and 4, is not a subarray because it skips over the -2. And likewise, 2 and 4 is also not a subarray because it skips over 3 and -2. So yeah, so in this case, 2 and 3, it skips like the largest product. So, and here there's some constraints. So we know that nums has at least one element. So we don't have to worry about nums having no elements at all. So let's go to whiteboard. Let's do a quick example. Suppose that this is our input array. Well, if the input array is all positives, then we know that the maximum product we can get from any subarray is just all these, like every single element multiplied together, was like 1 times 2 times 3, which gives us 6. But now let's take a look what happens when we have negatives. So suppose you have this, right? If we try the same approach, so let's say we do -1 times -2 times -3, we get -6. However, this is not the correct answer because here, -2 times -3 gives us +6, which is the largest product possible in this case. So what we're going to do is, and let me scroll over for a second. What we're going to do is we're going to keep track of both the current max and the current min. And the reason why we need to do that is because we need like a way to deal with negative numbers. So here are our variables. So we have current max. And this will be initialized to the first element in the input array. So we're also going to have current min. And likewise, this will also be initialized to the first element of the nums array. And we're also going to have the result, where I'll just call it res. And this will also be initialized to the first element of the input array. And res is what we're going to be returning. And yeah, so like I mentioned before, right, we need to keep track of both the current max and the current min so that we can deal with the negatives. And so what we're going to do is we're going to loop through the input array starting from the second element. So we can skip the first element because all 3 variables are initialized to the first element, right? So in each iteration, here's what we're going to do. We're going to first update current max. And this will be the maximum between the following items. The number, like the element itself, the element times, I'll use this as times, current max, and the element times current min. Let me scroll down a bit. Okay. And then we're also going to update current min. And it's going to be the same as above, but this time it's going to be minimum instead of maximum. But there's a problem with this, specifically with this part. We just updated current max, right? But we want to use the previous value, like the value before current max was updated. So what we're going to do is we're actually going to have a temp variable that's set to current max. And we're going to have a temp variable that's set to current max before current max is updated. So temp still has the old value of current max. And we're going to use temp instead. And lastly, we're going to update the result. And res will be the max between itself and current max. And finally, we're going to return current max. So let's do a quick example. Oops. So let's do a quick example. Suppose that the nums array is this. So we know that the expected answer is going to be 6. So at the beginning, so Cmax is set to -1. Current min is also set to -1. And the answer is also set to -1. And so in the first iteration, our n is equal to -2. Okay, remember, we're starting from the second element because we already initialized all 3 variables to the first element, right? So we can skip it. We're looking at the second element. So Cmax is the max between n itself, so -2, -2 times Cmax, which is -1, and -2 times current min, which is again, it's still -1. So Cmax is set to 2. Oh, sorry, I forgot. Here. Yep. Temp is equals to -1. And then Cmin is going to be the minimum between -2 times -1 and -2 times -1. So this will be equal to -2. Let me scroll down a bit. And our res is going to be the maximum between itself, which is -1, and current max, which is 2. So this is set to 2. So Cmax, this is set to 2. Current min is set to -2, and res is set to 2. Okay. Now, let's look at this the second iteration. So here, n equals to -3. Temp is equals to 2. Current max is the maximum between n, it's -3, n times Cmax, so -3 times 2, and n times current min, so -3 times -2, and this is 6 because of this part here. Now, do you see why we need the current min? And then current min or Cmin is the minimum between -3 times 2 and -3 times -2. which is -6, and the rest is going to be 6. And that's what we return. So now let's see this in code. So again, oops, we have a cur max, which is set to num0, the first element in nums. We have a cur min, also set to num0. And we have a res, which is also set to num0. And now we're gonna loop we're gonna loop through the nums array. And like I mentioned before, right? We start from the second element, so in x1. Here we're gonna have a temp variable to store the cur max value. Cur max will be updated to this. And cur min will be the minimum between the same thing. Except like I mentioned, instead of cur max, here we're gonna have to use temp. And then res is updated to the maximum between itself and cur max. And finally, we return res. Let me just double check I didn't accidentally misspell anything. Okay, so let me do a quick test run. Okay, let me submit this. And yep, you can see that this is a valid solution, and the time complexity of the solution is O of n because we are just looping through the nums array once. Thank you all for watching.